Now, we've spoken about intersecting lines and what happens when those lines intersect. So let's talk about the first one first. Corresponding. Just watch, guys. You've already taken these notes down many times. Corresponding angles. All right. Here is a pair of corresponding angles. Okay? The visual representation of corresponding angles is a whole lot better than saying anything. Okay? But the reality is they're on the same side of both of the lines and the same side of transversal, right? So top right. You see that? Another example would be bottom left, right? You guys understand this, what corresponding angles are? That's a pair of corresponding angles. What do I know about corresponding angles? They're what? Congruent. They are congruent. Okay? Next, alternate interior. Or rather than that, let's go straight to vertical angles. Vertical. If I have a pair of vertical angles, this could look like this. Vertical angles, right? They're across the vertex from one another. You see that? Those are vertical angles. What do I know about vertical angles? They're what? Congruent. Okay. Next. Alternate interior. Alternate interior angles are on the inside, right? And on the opposite side of the transversal. What do I know about alternate interior angles? Congruent. Okay. Next, alternate exterior. Sounding like a broken record here, but I know about alternate exterior angles. They're on the outside and an alternate side of the transversal. And what are those? Congruent. Does that make sense, guys? Okay? Look, we've learned about these many times. All right? Yes, sir. I'm also putting this on YouTube. Okay? Now, same side. same side, interior. So on the same side of the transversal and on the inside. What do I know about those two? They're supplementary. And then same side exterior. On the outside, but on the same side. And what are those? Supplementary. So all of them are congruent. All the pairs of angles are congruent, except for these ones that are same side. Can't get any simpler than that. If it's same side, then they're supplementary. If they're not same side, then they're congruent. Okay? Does that make sense to you guys? Any questions about that? Okay. But now we have to look into one thing. Okay? This was only true because I said to you that these lines here were parallel. All right, and when I draw an arrow on it like that, and those arrows are the same, that means they're parallel. That's how I show two lines are parallel. Draw little arrows like that. Okay? So let's call this line P, this line Q, and this line L. Which one is the transversal? What would you say, Olivia?
Is that an L?
L. Line L is the transversal. Okay? All the things I just told you are only true if these lines are parallel. So basically what I'm saying to you is, if lines P and Q are parallel, then corresponding angles are congruent. What does that sound like? What kind of statement? A conditional statement. If, then, right? If the lines are parallel, then the angles are congruent, right? So let me write that out. Let's talk about corresponding angles first. Okay? If line P is parallel to line Q, then let's call this angle 1 and angle 2. Then angle 1 is congruent to angle 2. Okay? Now, what is the converse? So that's my if-then statement. What's the converse? What does the converse do? Swaps it. So what would the converse of this statement be? The converse of the statement would be if angle 1 is congruent to angle 2, then line P must be parallel to line Q. You guys see this? Well, hey, that makes a lot of sense, right? If I've got two lines and they're being intersected by the same transversal, and this angle is congruent to that angle, then those lines must be parallel. You see? So this here is the corresponding angles postulate. If the two lines are parallel, then corresponding angles are congruent. That's the corresponding angles postulate. Okay, let me write that down. That's the corresponding angles postulate. And the corresponding angles postulate says that if these two lines are parallel, then the corresponding angles are congruent. You guys agree with that? Right? Well, this is the converse, right? That's the converse of that conditional statement, right? So what should I call it? I should call it, it's right there on your reteach. What does it say right there on the top of your reteach? Go ahead and look at it. No, right below that, sorry. The converse. It's not just a random word. We learned what a converse is. It's the converse of the corresponding angles postulate.
So the corresponding angles postulate is the reverse definition of the converse of the corresponding angles postulate?
The converse is the converse. Right? It's not a new thing. It's just the converse.
Yeah, just trying to.
Does that make sense?
Yeah, just I don't know which definition.
The corresponding angles postulate says if two lines are parallel, then corresponding angles are congruent. Okay? Right? The converse of that says if the corresponding angles are congruent, then the lines are parallel. Does that make sense to you guys?
Yeah.
You understanding this a little bit? Okay.
If two lines are parallel, then what?
If two lines, the corresponding angles postulate says if the two lines are parallel, it's right here. If two lines are parallel, then corresponding angles are congruent. Okay? And the converse says if the corresponding angles are congruent, then the two lines are parallel. So now let's take a look at this. Let's say that I've got line J, line K, and line L. All right? And I tell you that this angle is 57 degrees, and I tell you this angle is 57 degrees. If I know that both of those angles, what do I know about them? The measures are the what?
Same.
So what do I know about those two angles? They are congruent. Are those corresponding angles? Yeah. So those two corresponding angles are congruent, right? Well, what do I know about line K and line L? And how do I know that? The converse of the corresponding angles postulate. Understand? These two angles are congruent. These two corresponding angles are congruent. Therefore, I know those lines are parallel. How do I know those lines are parallel? Because the converse of the corresponding angles postulate. Does that make sense? You understand what we're showing here? Okay? That's how I know. Okay? Because the converse of the corresponding angles postulate says that if two corresponding angles are congruent, then the two lines are parallel. You see? Okay? Now, that's a lot of language. I realize that. So how do you think about it in a way that doesn't get confusing? These two angles are corresponding, right? Are they congruent?
Yes.
Yeah. So what do I know about those two lines? Parallel. Right? That's it. That's the logic. That's the logic. The rest is the language. You understand? Don't get confused by the language to make you think that you don't understand the simple concept. The concept is simple. It's the language that gets a lot, right? So listen, if I ask you why, you just say something, corresponding angles. Okay, and then what's that thing? Oh, converse. Converse of corresponding angles postulate. You understand? Okay? All right. Now, let's do the next one. alternate interior angles. Alternate interior angles. This is angle 1, and this is angle 2. And I tell you that angle 1, I say if, I'll use the same ones I used before, P, Q, and L. I say if angle 1 is congruent to angle 2, then line P is parallel to line Q. Okay? And how do I know this? Oh, I'm sorry, whoops. Sorry. If these lines are parallel, then I know, what about alternate interior angles? They are what? If the lines are parallel, then those two alternate interior angles must be congruent. Angle 1 is congruent to angle 2. And why do I know that? That's the alternate interior angles postulate. You understand that? Okay, it's the alternate interior angles postulate. Follow me, guys. Stay with me. Yeah. Okay, it's the alternate interior angles postulate. What's the converse? What does the converse do? Converse swaps it. Okay? If the converse swaps it, what's the converse of this? No. It swaps it. If angle 1, yes, Andrea, is congruent. Okay? Look, I'm proving that these lines are parallel. What does lesson 3.3 say? What's the lesson called? Proving lines parallel. I'm proving that these lines are parallel. How? Because if these two angles are congruent, if these two alternate interior angles are congruent, then what must those lines be? Parallel. If these two angles are congruent, these two lines must be parallel. Does that make sense to you guys? You understand that? Those two lines must be parallel. And this is called the converse of the alternate interior angle postulate. Do you understand? You understand what we're doing? I could keep going on and on. Alternate exterior angles postulate. The alternate exterior angles postulate says if two lines are parallel, then alternate exterior angles are congruent. Right? So if I show that alternate exterior angles are congruent, then the lines must be parallel. Please stay awake, Mr. McDougall. Please stay awake. Marcus. Stay awake, whatever you gotta do. Go run to the bathroom and splash water on your face. Go ahead. Go ahead. Thank you. Look. This is the idea. Okay? Now guys, I want you to understand something. Okay? Let's create a table. Let's create a table. Okay? The conditional statement. And the converse. Okay? You know what? There's corresponding. You know, don't worry about this table real quick. Just watch. There's corresponding alternate interior, alternate exterior, same side interior, same side exterior, right? All of them have a conditional statement and a converse. the conditional statement proves that the two angles are, corresponding angles are congruent, alternate interior angles are congruent, alternate exterior angles are congruent. That's what the conditional statement says, the regular postulate. Okay? The postulate. I should say postulate. What do I know about same side, interior and exterior? They're not congruent. They're what? Supplementary. 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 Okay? All of the postulates, the corresponding angles postulate says corresponding angles are congruent. For alternate interior angles, it says the alternate interior angles are congruent. For alternate exterior, it says they're congruent. For same side interior and exterior, it says they're supplementary. But all of those are dependent upon the two lines being what? Parallel. If the two lines are parallel, then this is true. The converse says that if these are true, any single one of them, it doesn't matter, then the lines are parallel. Do you understand that?
Yeah.
All the converses basically are just telling you that the lines are parallel. Does that make sense to you guys?
Yeah.
Listen, does that make sense? All of these, the postulate says these angles are congruent, these angles are supplementary, but the converse, but those are all dependent upon the lines being parallel. Okay? The converse says if this is congruent, these two angles are congruent, then the lines are parallel. If these are supplementary, then the lines are parallel. Does that make sense? The converse is proving the lines are parallel. Okay? Yes, ma'am. It's just a word. Yeah, it's just a word. It's just a math word. Okay? Now, reteach. Okay? Flip to your worksheet. Reteach. Okay? And let's take a look. Okay? Don't confuse yourself. Make your life easy. That's the key here when there's a lot of language. Look, number 1. It says given angle 2 is congruent to angle 4. How would I describe that pair of angles? What are they? Corresponding. They're on the same side and the same side. Okay? Corresponding angles. Okay? What's it asking me to do?
Use the converse of the corresponding angles postulate and to give information to show
C is parallel to D. Well, wait a second. If these two angles are congruent and they're corresponding, what do I know about C and D? They're parallel. So I don't need to do anything. That's just given. And then I say, guess what? C is parallel to D. How do I know? The converse of the corresponding angles postulate. C cap. Okay? If you want to abbreviate it when you're doing things like this, that's fine with me. Okay? But just make sure you understand. You don't have to write it out every time, but make sure you write the right abbreviation. You write C DAP or C flap or something. I don't know. C caps. Converse of the corresponding angles postulate. That's it. I'm done. That was the question. Good job. You aced the test. You understand? That's the question. That's the answer. That's it. That's it. That's the whole thing for that one. You understand? But you have to know what the converse of the corresponding angles postulate is. It's what's telling you that if these two angles are congruent, then those two lines are parallel. Do you understand that? Okay? It's a lot of language, but the reality is the concept is simple. You understand? Okay. Okay. Now, number 2, they make it a little bit more challenging. Now they say the measure of angle 1 is 2x, and the measure of angle 3 is 3x minus 31. Okay, but then they tell you x is 31. So what's my first step before I do anything else?
Plug it in.
Okay. Let's plug it in, right? Because I don't want to leave it like that, right? If I just have what x is equal to, it's almost arbitrarily difficult. You understand this? I could have just plugged it in for you, right? It's crazy. It's all good, though. But so what's your first step? The measure of angle 1 equals 2 times 31, which equals what? What's 2 times 31, class?
62.
62. Okay, and what's the reason? What did I just do? What did I just do? But how did I get the 31 in there for x? What did I do? Substitution. Substitution. Okay. Measure of angle 3 is equal to 3 times 31 minus 31. Well, 3 times 31 is what, class? 93 minus 31 is? 61. Good. 62. 62 degrees. And what did I do?
Substitution.
Substitution. Okay. Well, measure of angle 1 is equal to 62 degrees. And measure of angle 3 is equal to 62 degrees. That's great. Now what?
Set them equal to each other?
Yeah. I know that they're equal. Therefore, measure of angle 1 equals measure of angle 3. Okay? And what's that property that if there's two things are equal to the same thing, that are equal to each other? What is it?
Reflective.
Not reflective.
Transitive.
Yes! For the win! Supermarket sweep. Let's throw a turkey in there. You guys don't know what that is. You guys don't know what that is.
What is that?
It's an awesome show from like old school. Transitive Po.
What is it called?
Supermarket sweep. All right. The measures of the two angles are equal because they're both equal to the same thing, right? That's a transitive property of equality. Okay? Now, if the measures are equal, what do I know about the angles? They're congruent. Angle 1 is congruent to angle 3. And how do I know that? Definition of what? Congruent angles. The definition of congruent angles. That's the definition of congruent angles. So definition of congruent, you can write it just like this, congruent angles. Okay. So I substituted in, I saw that they're equal. If I know these two angles are congruent, these two corresponding angles are congruent, what am I trying to prove again? What's the whole reason I'm doing this? I'm trying to prove what? The two lines are parallel, right?
Yes.
Well, if those two angles are congruent, what do I know about those two lines? They're parallel. I know that C is parallel to D, and how do I know that? The converse of the corresponding angles postulate.
Will it ever be just corresponding angles postulate?
If you're proving that the angles are congruent. If they're asking, hey, these two lines are parallel, prove that the two angles are congruent. Oh, well, angle 1 and angle 3 are congruent because of the corresponding angles postulate. If you're asked to prove that the angles are congruent, then you're just using the regular one. The corresponding angles are alternate interior or alternate exterior. Do you understand? But if you're proving the lines are parallel, you see the difference? You're proving the lines are parallel, you're always using the converse. That was a very good question, sir. Very good question. Any questions about that? Yes, sir. Just 1 minute. Do you guys, hold on, just 1 minute. You okay? Okay. Do you guys understand what I'm saying, what I'm showing you here? Now, these same things apply to alternate interior angles, alternate exterior angles, same side interior, and same side exterior. The same rules here. If I'm proving the lines are parallel, I go through the same exact process. Okay? It's just, I would go through the process for the different pairs of angles. Do you understand what I'm saying to you? Do you guys understand what I did? In both of these cases, I proved that the lines were parallel. You understand? Okay. In both of those cases, I proved that the lines are parallel. Now, go ahead and flip to your other reteach. Okay. Now, here it says, use the theorems in the given information to show that J is parallel to K. It says angle 4 is congruent to angle 5. So let's highlight that. Angle 4 is congruent to angle 5. There's angle 4, there's angle 5. Well, how would I describe that pair of angles? They are what? Alternate interior. Those are alternate interior. Why? They're on the inside and the alternate side of the transversal. So they're alternate interior angles. Well, if those two angles are congruent, what do I know about those two lines? They're parallel. So line J is parallel to line K. And how do I know that? The converse of the, not the corresponding angles, but the alternate interior angles postulate. So the converse of the alternate interior angles postulate. CAIAP. Okay? See that? You see how it's basically the same exact process there? Just, those two angles are congruent. They're alternate interior angles. So the two lines are parallel by the converse of the alternate interior angles postulate. Let's continue. Number 4. You see how this one is exactly the same as the other one? This one says measure of angle 3 is 12x. Here. Yeah?
They end with theorem, not postulate.
What?
It says converse of alternate interior angles theorem.
Okay, sorry. You know what, honestly, it's all good.
Same thing.
There's a slight difference. There's a theorem. So it's theorem, postulate. Guys, I'm not going to take off points if you put theorem instead of postulate or postulate. I'm not going to. Just do it as far as you can remember, but I will not take points off if you mess up theorem and postulate. Just show me you understand. You get it? Okay? All right. So measure of angle 3 is 12x. Measure of angle 5 is 18x. Okay? So an x is equal to 6. What's my first step? Substitute, right? X is 6, so 12 times 6 is 72 degrees. And I do that by substitution. Okay? Measure of angle 5 equals 18 times 6, which is 108 degrees. And I do that by substitution. Okay. Then look. I have this one is 72 degrees and that one's 108 degrees. These are what? What are they? They're interior on the what side? Same side. So I know they should be what? Supplementary. They're same side, they should be supplementary, right? So I should show that they add up to what?
180.
180. So in order to show that, I should add them together, right?
Yeah.
So I'll show that m of angle 3 plus m of angle 5 equals 72 degrees plus 108 degrees, right? And I do this by the addition.
Teachers and students, and pardon this interruption. This is just a reminder for those students who have been selected for the homecoming court for this year's homecoming to please come to an informational meeting in Mrs. Quinton's room immediately after school. Again, please come to Mrs. Quinton's room immediately after school on the 4th floor. Thank you very much.
Okay, look. I add the two together, addition property of equality, right? Okay. Well, what do I do now? I just simplify. M angle 3 plus M angle 5 equals 180 degrees. I do that by simplifying. Are you guys following this?
Yeah.
Okay, well, if those two angles add up to 180 degrees, what do I know? That they are? Okay. Angle 3 and angle 5 are supplementary. And how do I know that? What's my justification?
Definition of supplementary.
It's the definition of supplementary angles. Or the definition of supplementary. Okay? Does that make sense? Right? So I found that N3 was 72, 5 was 108. Added them together, I found they're 180, so they must be supplementary. Well, wait a second. If these two angles are same side interior and they're supplementary, what do I know about line J and K?
They're parallel.
They're parallel. I know that line J must be parallel to line K. And how do I know that?
Because they're supplementary.
She's out there. I thought she was coming in.
By the converse, guys, let's stay focused. Let's not back up yet. The converse of the what? What kind of angles are those?
Oh, the converse.
They're on the same side, interior.
Oh, there's same side.
So converse of the same side interior angles postulate. Okay? Don't confuse yourself. It's just, they're the same side angles, right? Same side interior. So which theorem do you use? The converse of the same side interior angles. Converse of the same side interior angles theorem. Okay? You guys understand this? Okay. Now, there's one more on the reteach. I'm not going to be able to get to it, but you see how it's basically the same idea here? Okay. Now, what's your homework? Your homework is practice A and practice B. Okay? Practice A and practice B. All right. Thank you guys for your attention. This lesson is going to be on YouTube, so you guys can go ahead and pack up now.